Today I'm going to talk about MST, and I'm going to use Kruskal's algorithm to talk about how to find MST. And the first thing that I want to mention about MST is that we're trying to find a minimum spanning tree. By minimum spanning tree, we mean that the path that we get out of running this algorithm should be minimum, and it should span the whole graph. So it means that all of these nodes are going to be in our outcome, and it should be a tree, which means we are not going to have any cycles. To deal with cycles, we use disjoint sets. Okay, now let's get started. So the first thing that we see in this priority queue is going to be v7 v6 because it has the weight v1. So that is the smallest element that we can get out of the priority queue at this moment. We check the parent of v7 and the parent of v6. The parent of v7 is itself right now because in this joint set it's not connected to anything yet, and the parent of v6 is v6 itself because it's not connected to anything in the disjoint set. So in this case, we're gonna take v7, v6 out of our priority queue. We're gonna color the edge that we just saw. So we're talking about v7, v6. So it's gonna be this guy right here, and we're also gonna make the parents of v7 and v6 to be the same. So let's say that we put the parent of v6 to be v7. Now v6 has parents v7 and v7 has the parent itself. So now their parents are connected to each other. The next smallest thing that we see in this priority queue is going to be v1, v4. And v1 has parent v1, which is because v1 is not connected to anything yet. And v4 has parent v4 because v4 is not connected to anything yet. Okay, so now you're gonna take this 2 out and put the parent of 1 equal to the parent of the other one. So v4 is gonna have parent v1 right now, and v1 has parent v1 as well. So their parents are now pointing at the same thing. Okay, so let me also color that one on this graph. So v1 v4, which is this guy, now is visited, and we move on to the next smallest element in our priority queue, which is going to be v1 v2. v1 v2 is this edge here, and as you see, v1 has parent v1 and v2 has parent v2 because v2 is not connected to anything yet. So their parents are different, so that's going to be a valid option for us to get out of the priority queue. So now I'm gonna call the parent of v1 to be connected to the parent of I mean the parent of v2 to point at the parent of v1. So now v2 and v1, v1's parent are calling to the same parent, and I'm gonna also color this edge here. Then I move on to the next smallest element in this priority queue, which is gonna be v3, v4. v3 has parent v3 because v3 is not connected to anything yet, and v4 has parent v1. Okay, so the parents of v4 and the parent of v3 are different, so that's another thing that I can take out of the priority queue. So now I'm gonna say that here I have v3, and I point the parents of v3 to point at the parents of v4. So v3 now is pointing at v1, and I'm gonna also show it on the graph here. So I'm always talking about v3 v4, which is going to be this guy here. Now the next thing that we're going to do is to take the next smallest element, which is going to be v2 and v4. Now look at the graph first. So v2 and v4 is going to be this edge here, and as you see, we're going to have a cycle if we add that. Now look at the disjoint set that we have here. v2's parent is going to be v1, and v4's parent is going to be v1 as well. So that is an obvious case of cycle. Okay, because this disjoint set is telling us that it's going to be a cycle. We're not going to add v2 v4 to our minimum spanning tree. Now we move on to the next smallest element in our priority queue, which is gonna be edge with the weight 4. So v3 v1. v3 v3's parent is v1, and v1's parent is itself. Okay. Now because they have the same parent, we're not gonna add this edge neither. And as you see here, v3 v1 is this edge right here, and you can see the cycle that we make if we pick this one. So we're gonna ignore that. We go to the next element, which is gonna be v7 v4 with a weight 4. So v7 v4 is this guy here. As you see, we're not gonna have any cycles. Now let's confirm that with our disjoint sets. So we're talking about v7 and v4. So v7's parent is going to be v7 itself, and v4's parent is going to be v1. So they have different parents, so we can definitely pick that one as the next answer, and we join the parents of v7 and the parents of v4 together. So let's first show it in the graph. So we're talking about v7 v4, we're talking about this edge right here, and we're also connecting their parents. So now v7's parent is itself, and it's connected to v1. So now we're gonna have v7, and then we're gonna have v6. Then we can get rid of this guy. Okay. Then the next smallest thing that we take out of our priority queue is gonna have a length 5. Okay. So v6, v7. We look at the parent of v6. The parent of v6 is gonna be v6 is gonna be v1, because v6, v7, v1, and the parent of v3 is going to be v1 as well, because v3 is having a parent v1. Now we can't add the pair v6 v7 because it's going to make a cycle, and as you see here, v6 v3 is going to be this edge here, and you can see this huge cycle. So we should avoid that, and we move on to the next smallest, which is going to be v5 v7. v5 v7 is this edge right here, and as you see, that's a pretty valid thing to pick next. And let's confirm it with our disjoint set. So v5 v7, v5 is not connected to anything, so v5's parent is just v5, and v7's parent is v1. So they have different parents, so that's going to be a pretty good choice for us to pick next. So v7 v5. Okay, I'm also gonna connect the parents of v5, which is v5 itself, to the parent of v7. The parent of v7 is v1, and the parent of v5 is v5 itself. So v5 is going to be now connected to the parent of v7. And as you see here, we have like all of the vertices, okay, connected in this disjoint set. When this happens, it means that you have visited all of the nodes, and you have them in your MST, and that is when you can stop the algorithm, or you could continue until this priority queue is completely empty. And that's how you do Kruskal's algorithm to find MST.